Okay, number 12. First thing we want to do is check and see if we can simplify anything here. Multiply to 40, subtract to 3, 8, and 5. Since we subtracted, we have different signs. On our denominator, multiply to 64, add to 16, minus 8 and minus 8. One of the minus 8 simplifies. In my second, I always want to make my variable positive if I could. So I'm going to divide out a -1 on both of those. I'm going to have k plus 8. So I'm just going to rewrite here what we have. Right now I have k plus 5 over k minus 8 minus 3 over k plus 8 and another negative. When I have two negatives, guys, I can make a positive. So right now I have k plus 5 over k minus 8 plus 3 over k plus 8. My common denominator is going to be k minus 8, k plus 8. In my first fraction, I'm missing the k plus 8. So I'm going to multiply by k plus 8, denominator and numerator. In my second, I'm missing the k minus 8. So I'm going to go ahead and multiply by k minus 8. And again, whatever we do to the denominator, we have to do to the top. I have to simplify here, and so in order to do that, I'm going to FOIL. K squared plus 5 plus 8 gives me plus 13k plus 40 over my LCD plus 3k minus 24 over our LCD. Now that I have them both over my LCD, I'm going to just combine them into one fraction. K squared plus 15k plus 16 over my LCD. And my LCD here, I'm going to rewrite as k plus 8, k minus 8. And there is, first of all, I should add correctly. It should be a 16. Sorry. K squared plus 16k plus 16. I knew something didn't look right. I can't simplify that. There's nothing that multiplies to 16 and adds to 16. So this is my final answer. Keep in mind, k cannot equal 8 or -8. Okay, if we wouldn't have simplified out this k minus 8 right away, that would have been fine. We could have eventually done it in the end. Same thing if we had kept it as a negative and multiplied by a negative. We would have just had all negatives in our numerator and it would have worked the same way. Okay, we would have still gotten to the same answer. We'd have just had to divide out the negative at the end. Simplifying complex fractions here, we have fractions inside of fractions. So we're going to treat them like two different problems to start with and then combine them. So check our numerator. I cannot simplify that any further. Okay, my denominator though, I can. Right now I have two different things added together. I only want one. Like I have 4 over x plus 3 is one thing. And my denominator, I want one expression as well. So my common denominator is going to be x. Right now I have 3 over 1. So my common denominator is an x. My first fraction, I have it. My second one, I don't. So I multiply top and bottom by x. This gives me 1 plus 3x over x when I write it as one fraction. So right now I have 4 over x plus 3 all over another fraction of 1 plus 3x over x. How do I divide fractions? Okay, just like we did on problems 5 and 6. Okay, we're doing the same thing here. It just looks different because it's written in fraction form. But we're still just dividing right here. And to divide fractions, we multiply by the reciprocal. So I keep my first fraction, or my numerator, exactly as is. I switch from division to multiplication, and I take the reciprocal of my denominator. Top goes to the bottom, bottom goes to top. So I have x over, I'm going to put the 3x first. It does not matter, it's just usually we put them in standard form, which means variable first. When we're multiplying fractions, we don't need common denominators, we don't do anything except multiply straight across. So I'm going to have 4x over x plus 3 times 3x plus 1. And there's nothing I can simplify there. Some of you might have had 3x squared plus 10x plus 3. That would have worked just fine as well as your denominator. Keep in mind here that at no point can our denominator be 0. So x plus 3 cannot be 0, which means x can't be negative 3. It can't be 0. And right here, 3x plus 1 cannot be 0. Subtract 1, divide by 3. X cannot have been negative 1/3. So keep that in mind as well. I know it doesn't explicitly say that, but something to keep in mind. Same idea here for 14. Simplify your numerator, simplify your denominator, then divide. So common denominator here right now, I have x over 1. So between 1 and y, it's a y. Multiply my second by y in the denominator, which means I do in the numerator as well. So right now, I have yx plus 4x over y all over 7 over 3x. That's my big division line. If you want to here, you can factor out an x that's common. Don't need to. Okay. To get rid of division, I switch to multiplication by the reciprocal of my denominator. So I move the 3x to the top and the 7 to the bottom. And now that I have fractions, I can multiply straight across. So I can take y times x plus 4x times 3x over 7y. Keep in mind here, y cannot equal 0, x cannot equal 0, and here I just have y again. So those are my only restrictions. You could have ended here. We could have written it a little bit cleaner as 3x. I could have factored out the common x here. So x times x is x squared. 4 plus y, or y plus 4, over 7y. Either one of these would have worked. So before I simplified, or my final answer here, I would have accepted either of them. Okay, so either 3x times xy plus 4x all over y, 7y, sorry, or 3x squared times 4 plus y, or y plus 4 over 7y, or anything in the middle there. Okay, 15. Again, same idea. Simplify your numerator, simplify your denominator. So, y minus 1, factor, I need to multiply to 6, subtract to 1. It's positive 1, which means positive 3, and a minus 2. All over my denominator, there's nothing I can simplify. I've simplified it the best I can. Now, to get rid of my division, okay, think of this complex fraction right now as a big division sign where we plugged this fraction in here and this fraction in here. Okay. So I keep my numerator exactly as it is, and instead of dividing, I switch to multiplication by the reciprocal. Top goes to bottom, bottom goes to top. My new numerator is going to be what used to be my denominator, and my new denominator is what used to be my numerator. When we multiply fractions, we multiply straight across. So I multiply both of those. And when I take something divided by itself, as long as they're all factors, I get 1. So right now I have y minus 1 over y minus 2, y minus 6. And some of you simplified that to y squared minus 8y plus 12 in your denominator. That would have worked just fine. Or this would have been fine. Just remember that y cannot equal negative 3, positive 2, negative 3 again, or positive 6. 16 here says, if R is the total resistance of a parallel circuit with two resistors of resistance R1 and R2, then 1 over R equals 1 over R1 plus 1 over R2. Sounds like a lot here, but we're looking for resistance R1, so we're looking for this. R is 35. And R2 is 80. So lots of different things we can do here, guys. First thing we could do is we can simplify our left side, or our right side, or we can get our R term by itself. I got the R term by itself because we're dealing with numbers. So I subtracted 1 over 80. 1 over 35 minus 1 over 80. You can type that in your calculator. Common denominator, guys, is going to be 560. You're going to get 9. We could have multiplied, if you don't want to find your common denominator, by an 80 here, top and bottom, and a 35 here, top and bottom. 80 minus 35 over 80 times 35. We're going to get 45 over whatever 80 times 35 is. It's going to simplify down to 9 over 560. I don't have my calculator on me. But you guys could have just typed 1 over 35 minus 1 over 80 either as division or as fraction in your calculators and switched it to a fraction, and it would have worked just fine. Now, we can either clear our fractions or think about them as proportions and cross multiply. Either way, it's going to work the same. So I'm going to take 560 times 1 equals 9 times R1. It's going to be 560 equals 9, R sub 1 divided by 9, and R sub 1 is going to be approximately, it's going to be exactly 62.2 repeating, I believe, but it says round to the nearest ohm, so we want 62. I think this is how you label ohms. I'm not sure. If you're not sure, just write ohms. This could be wrong. I don't know. I'll have to ask Miss Rusfold. But there we go.